Hi students, today in this session I am going to discussing some concepts on the circle and some objective problems on these concepts. Okay, let us start this. See that the locus of a point which moves in a plane such that a constant distance from a fixed point is called a circle, where the fixed point is called the center and the constant distance is called the radius. This is the definition of the circle. First of all, we must know the definition. What is the definition? The locus of a point which moves in a plane such that a constant distance from a fixed point is called the circle. Here the fixed point is called the center and the constant distance is called the radius. It is the definition of the circle. Next, the equation of a circle with the center at x1, y1 and radius r is x minus x1 whole square plus y minus y1 whole square is equal to r square. This is the center radius of the circle. If we given center x1, y1 and radius is r, then what is the circle equation? X minus x1 whole square plus y minus y1 whole square is equal to r square. Okay. Next, the equation of a circle with the center at origin and radius r is the circle x square plus y square is equal to r square, which is called the standard circle. This equation is called standard circle. This is the circle with center at origin and radius small r. Okay. Next, the general equation of the circle is x square plus y square plus 2gx plus 2fy plus c is equal to 0. This equation is called the general equation of the circle. What is the center of the circle? Minus g minus. That is nothing but minus x quotient by 2 comma minus y quotient by 2. These are the coordinates of the center of the general equation of the circle. Next, what is the radius? R is root of g square plus f square minus c. This is the center and radius of the general equation of the circle. Next, see that if x1, y1 is one end of a diameter of a circle s is equal to 0, then the other end is the formula minus 2g minus x1 comma minus 2f minus y1. These are the coordinates of the other end of the diameter of the circle. If we given one end of the diameter is x1, y1. See the diagram. This is the circle. x1, y1 is one end of the diameter. Then the other end of the diameter is minus 2g minus x1. That is x coordinate. And y coordinate is minus 2f minus y1. Next, the conditions for general equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. This equation, this is the second degree equation. It represents a circle. These are the conditions. First condition, a is equal to b. That is quotient of x square is equal to quotient of y square. And the second condition is h is equal to 0. That is the quotient of xy is equal to 0. Next, see that the standard form is a circle, that is x square plus y square plus 2gx plus 2fy plus c is equal to 0. Sometimes it is called general circle equation of general equation of circle. Sometimes it is also called stand form of the circle. So this circle is represents these are the cases. If g square plus f square minus c greater than 0, then this circle is called a real circle. What is the here? G square plus f square minus c. What is the radius of the circle? R is equal to root of g square plus f square minus. In that g square plus f square minus c is positive, that is greater than 0. Then we are getting a real value for radius. So then the circle is called a real circle. So next case is if g square plus f square minus c is equal to 0, then the radius becomes a 0. So this circle is called point circle. When g square plus f square minus c is equal to 0, then that equation represents a point circle. Next case is g square plus f square minus c is less than 0. That is radius is r is we are getting imaginary value. Then in that case the circle is called imaginary circle. So these points are very important for objective problems. So we are given the equation of the circle. So in the options it is a real or point circle or imaginary or none of these. So first we have to observe g square plus f square minus c. It is positive value, then it is a real circle. If it is negative value, it is an imaginary circle. If it is 0, then it is a point circle. Okay. Next a line lx plus my plus n is equal to 0 meets the circle x square plus y square is equal to a square in capital A and capital B. Then the equation of the circle whose diameter AB. Now I have to find the equation of the circle AB as the diameter. We have to given the circle x square plus y square is equal to a square and the line lx plus my plus n is equal to 0. The line meets the circle at 2 points capital A and capital B. Now we have to find the equation of the circle. These meeting points A, comma B as the diameter of the circle. So that circle is becomes using this formula. So this is the formula x square plus y square minus a square plus 2n by l square plus m square into lx plus my plus n is equal to 0. See the diagram. This is x-axis and y-axis. This is the line meets the axis at capital A and capital B. Now the equation of the circle AB as the diameter of the circle, that is the circle we are obtaining this one. Okay. Next see the another concept. The circle circumscribing the triangle formed by the coordinate axis and the line ax plus by plus c is equal to 0. So this is the line ax plus by plus c intersects the coordinate axis at capital A and capital B. Now we have to find the equation of the circle, circumcircle, that is the triangle of OAB. That is we are getting from this formula AB into x square plus y square plus c into bx plus ay is equal to 0. This is the formula for getting the circumcircle of triangle OAB. Okay. Next see that the centers of two circles are same, then the circles are called concentric circles. What is the definition of the concentric circles? When two or more circles having the same center. Two or more circles having the same center, then those circles are called concentric circles. See that the concentric circle of given circle is here x square plus y square plus 2gx plus 2fi plus c is equal to 0 is of the form x square plus y square plus 2gx plus 2fi plus k is equal to 0. So when two circles are concentric circles, only constant is differ. The remaining terms are all same. Why? These centers are same. When the centers are same, then the remaining terms are equal and only constant is differ. So the concentric circle of x square plus y square plus 2gx plus 2fi plus c is equal to 0 is of the form we are writing x square plus y square plus 2gx plus 2fi plus k is equal to 0. Okay. Next point, the equation of the circle a of x1 y1 b of x2 y2 are endpoints of the diameter of the circle. If we given endpoints of the diameter of the circle, what is the circle equation? This is the formula x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equal to 0. This is the circle AB as the diameter of the circle. Next, if x1 y1 if x1 x2 are the roots of the equation x square plus ax plus b is equal to 0 and y1, y2 are the roots of y square plus cy plus d is equal to 0. Then the equation of this circle having the line joining x1, y1 and x2, y2 as diameter is the circle. This is the formula for the required equation of the circle. X square plus y square plus ax plus cy plus b plus d is equal to 0. So, the given two quadratic equations x square plus ax plus b is equal to 0 and y square plus cy plus d is equal to 0. These two equations are added, then we are getting the required equation of the circle. Here x1, y1 and x2, y2 are the endpoints of the diameter of the circle. Here x1, x2 are the roots of first quadratic equation x square plus ax plus b is equal to 0 and ordinates y1, y2 are the roots of the another given equation y square plus cy plus d is equal to 0. Then the 2 points x1, y1 and x2, y2 are endpoints of the diameter of the circle is adding these two equations. We are getting x square plus y square plus ax plus cy plus b plus d is equal to 0. Another concept, the intercepts made by the circle, that is the general equation of the circle. X square plus y square plus 2gx plus 2fy plus c is equal to 0 on the coordinate axis. X-intercept is equal to formula 2 into root of g square minus c and y-intercept is the formula 2 into root of f square minus c. These are the intercepts made by this general equation of the circle on the coordinate axis. X-intercept is the formula 2 into root of g square minus c and y-intercept is 2 into root of f square minus c. These are the intercepts. So look at the diagrams. First diagram is the circle made by the intercept on the x-axis. Second diagram is the circle made by the y-intercept on y-axis. Okay, these are the intercepts made by the circle on the coordinate axis. Next, see that the circle with the diameter ends x1, y1 and x2, y2 makes an intercept on the axis. This is the diagram. X-intercept is the formula. So, we have to given that endpoints of the diameter of this circle. Now we have to find that circle intercept on x-axis. So, what is the intercept made by this circle? Whose endpoints are x1, y1 and x2, y2. Whose endpoints of the diameter are x1, y1 and x2, y2. That is the given. Then what is the intercept made by the circle on the x-axis? That is the x-intercept, the formula square root of x1 minus x2 whole square minus y1 minus 4 into y1, y2. This is the formula for finding the x-intercept made by the circle. So that circle endpoints of the diameter are given. Okay. Next, see the another formula. That circle y-intercept is the formula. Y-intercept is equal to square root of y1 minus y2 whole square minus 4x1 x2. This is the shortcut formula for finding the intercepts made by the circle. That circle having the endpoints of the diameter are given. x1, y1 and x2, y2 are the endpoints of the diameter of the circle. That circle makes the intercepts x-intercept and y-intercept. These are the formulas for finding the intercept made by that circle. Okay. Another method is also, we are first write endpoints of the diameter of the circle. Then we are getting the circle equation. After that, we find the x-intercept using the above formula 2 into root of g square minus c and y-intercept is 2 into root of f square minus c. Using that method is also. So this is the shortcut method. So finding the x-intercept and y-intercept if you are given the endpoints of the diameter of the circle. Okay. Next one. The circle touches x-axis. Then what is the condition? G square is equal to c. If the circle touches y-axis, then the condition is f square is equal to c. Look at the diagram. The first diagram, the circle touches x-axis. The second diagram, the circle touches y-axis. These are the conditions. If any circle touches x-axis, then the condition is g square is equal to c. And if any circle touches y-axis, then f square is equal to c. These are the conditions. Next point is the circle touches both the coordinate axis. If g square is equal to f square is equal to c, then this circle touches both the coordinate axis. Then this is the condition. Look at the diagram. This is the x-axis, y-axis, and the circle touches both the coordinate axis here. Then the condition is g square is equal to f square is equal to c. These are the conditions when the circle touches x-axis or y-axis or both the coordinate axis. Next one, we are using the notations in this chapter and coming chapter, system of circles. These are the generally we are using the notations. So first is the circle. General equation of the circle is notated by capital S. What is the capital S here? S is equal to x square plus y square plus 2gx plus 2fy plus c. This is the circle general equation of the circle, simply denoted by s is equal to 0. We are not writing all terms. Simply s is equal to 0. That means x square plus y square plus 2gx plus 2fy plus c is equal to 0. Next, what is S11? That is S11 is the notation. So given point x1, y1 is your substitute in the given circle. So we are getting x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. This is the value of S11. So this is notated by S11. What is S1? S1 is denoted this equation x1 plus y1 plus g into x plus x1 plus f into y plus y1 plus c. So this equation is represented by S1. What is S12? S12 is represented by the equation x1 x2 plus y1 y2 plus g into x1 plus x2 plus f into y1 plus y2 plus c. This is the notation for S12. So this equation represented by S12. Generally we are using these notations. Okay. Next one, parametric equations. So we have to done these all concepts in previous IP concepts. We are again remembering these concepts. Okay, what are the parametric equations? The parametric equations of a circle with the center at x1, y1 and radius small r. Parametric equations are x is equal to x1 plus r cos theta, y is equal to y1 plus r sin theta, where theta is the parametric angle of the point and it is lie between 0 less than or equal to theta less than or equal to 2 pi. Okay, these are the parametric equations where x1, y1 is the center and r is the radius and theta is the parametric angle. Okay, these are the parametric equations of circle. That is the variable point on the circle we are taken x comma y. That is x is x1 plus r cos theta, y is y1 plus r sin theta. Okay. Next, see the point. The vertices of a square which inscribed in the circle x square plus y square plus 2gx plus 2f5 plus c is equal to 0 of radius small r and whose sides are parallel to the coordinate axis. A square whose sides are parallel to the coordinate axis, that square is inscribed in this circle, general equation of the circle. Then we are writing the vertices. Then we are writing the vertices of the square using this formula. What is the formula? Minus g plus or minus r by root 2, comma minus f plus or minus r by root 2. These are the vertices of a square. So we are getting vertices using this formula. Okay. Next one. So these are the concepts we are already discussed in previous videos. Now we have solving some objective problems on these concepts. Okay, first one is the distance between two parallel chords, each of length 10 units, is 24 units. Then the radius of the circle. That is our problem. The distance between two parallel chords, each of length 10 units, is 24 units. Then the radius of the circle. Okay, what is the meaning of the question? So we have to given two parallel chords. See the diagram. This is the given circle. These are the two parallel chords. What is the distance between these two parallel chords? 10 units. Each length of the chord is 10 units. So these are the two parallel chords and each length is 10 units. And distance between them and distance between these two parallel chords is given 24 units. That is, here this is the diagram. So here this is like a rectangle. Here A, B, C, D is a rectangle. So A, B and C, D are two parallel chords and distance between these two chords is 24 units and each chord length is 10 units. That is the meaning behind this problem. Okay. Now we have to find the radius of the circle. So it is a rectangle. Now AC is the diagonal of the rectangle. So here ABC is a right angle triangle and here AC is the diameter of the circle. Here A and B and C are the points on the circle. Okay. Now here AC is the diameter of the circle. Okay. Now see the solution. Given that here AB and CD, these are the two equal chords which are parallel and these lengths of the chords is 10 units. And here AD and BC are the distance between these two parallel chords, that is given 24. Okay. Now from this diagram, AC square is equal to AB square plus BC square. Here AB is 10 and BC is 24. Now 10 square plus 24 square, that is 100 plus 576, that is 676. Then we are getting AC is equal to root of 676, that is 26. The length of AC is here 26. What is here AC? AC is the diameter of the circle. Now in this problem we have to find the radius of the circle. Therefore here AC is the diameter of the circle. The radius of the circle is AC by 2, that is 26 by 2, that is 13. So the radius of the required circle R is equal to 13. It is the answer of the question. Okay. Next, see that a rectangle of sides small a and small b is inscribed in a circle. Then its radius. This is the problem. A rectangle of sides are given small a and small b are the sides of the rectangle. A circle is inscribed in this rectangle. Then what is the radius? This is the rectangle. The circle is inscribed in this rectangle. So here A, B, C, D is the rectangle. Circle is inscribed in the rectangle. Now we have to find the radius of the circle. Here also AC is the diagonal. Now here AB is equal to, that is the length of the sides. AB is one side A, small a, and CD is another side small b. These are the sides of the rectangle we have to given here. Okay. Since AC square is equal to AB square plus BC square. Here AB is small a and BC is small b. That is AC square is equal to A square plus B square. From that, AC is equal to root of A square plus B square. AC is the diameter of the circle. Therefore, the radius of the circle, the required radius of the circle R is equal to half of the diameter, that is 1 by 2 into AC. What is AC? Root of a square plus b square. So radius small r is equal to half into root of a square plus b square. So this is the required radius of the circle. Okay, next one. See that the locus of the center of the circles which touches the line 6x minus 8y plus 5 is equal to 0 and 6x minus 8y plus 13 is equal to 0 is 6x minus 8y plus k is equal to 0. Then what is k value? So this is our problem. See the diagram. This is the circle. So here given three lines are parallel. Okay. So 6x minus 8y plus 5 is equal to 0 and 6x minus 8y plus 13 is equal to 0. These are the parallel lines which are touches the given circle. So look at the diagram. These are the two parallel lines which are touches the given circle. Now also given that the center locus of the center is the line 6x minus 8y plus k is equal to 0. That is the diagram. Okay. The equation of the line which is equidistant from the lines x plus by plus c is equal to 0 and ax plus by plus d is equal to 0 is ax plus by plus c plus d by 2 is equal to 0. This is the formula. So when we have to given two lines, now we have to find the locus of a line which is equidistant from these two lines. Is the formula, that is the bx plus by plus c plus d by 2. This is the constant of the required locus of the line. So in this manner we have to find the required locus of the center of the circle. So center of the circle line, that is parallel to the given two lines and which is equidistant from the given two lines. So the answer is 6x minus 8y plus c plus d by 2. Here c is 5 and d is 13. 5 plus 13 by 2, that is 18 by 2, that is 9. So 6x minus 8y plus 9 is equal to 0 is the locus of the center of the line. So we are comparing to the given line, k is equal to 9. Therefore, what is the answer? K is 9. Okay. Next one. The locus of the centers of the circle for which one end of the diameter is 1, 1 while the other end is on the line x plus y is equal to 3. Now we have to given one end of the diameter is 1, 1 and the other end is on the line x plus y is equal to 3. Now we have to find the locus of the center of the circle. It is our problem. See there, this is the circle. Here A is 1, 1 is one end of the diameter. Here C we are taken the locus of the point C is h, k, and the other end taken B of x1, y1, that is lies on the line x plus y is equal to 3. Now we have to find the locus of the center h, k. See that solution. Let B of x1, y1 be the other end of the diameter and C of h, k be the center of the circle. Now here since C is the midpoint of AB, here AB is the diameter. So then C is the midpoint of AB. Now we are equating the center h, k to the midpoint of A and B. Here A point is 1, 1 and B point is x1, y1. So what is the midpoint? x1 plus x2 by 2, y1 plus y2 by 2. So therefore C of h, k is equal to 1 plus x1 by 2, 1 plus y1 by 2. Now equating the midpoint, from that we are getting 2h is equal to 1 plus x1 and 2k is equal to 1 plus y1. From that we are writing x1 is equal to 2h minus 1 and y1 is 2k minus 1. So here x1, y1 is the point on the line x plus y is equal to 3. Now the point x1, y1 is substitute on the line. So here x1, y1 or substitute in the given line x plus y minus 3 is equal to 0, then we are getting 2h minus 1 plus 2k minus 1 minus 3 is equal to 0. From that 2h plus 2k minus 5 is equal to 0. Then we are writing the locus of center h comma k. That is in the place of h is x, in the place of k is y. Then we are getting the locus. The required locus of the center is 2x plus 2y is equal to 5. That is the required locus of the center. Okay. Next one, let capital P and capital Q are any 2 points on the circles. First circle is x square plus y square minus 2x minus 3 is equal to 0. And the second circle x square plus y square minus 8x minus 8y plus 28 is equal to 0 respectively. If small d is the distance between capital P and capital Q, then the set of all possible values of small d. We have to find the range of d. Here d is the distance between P and Q. Here P and Q are the 2 points on the given 2 circles. See the diagram. This is the first circle and this is the second circle. Now see that, look at the diagram. P and Q are the position of the points on the first circle, and on the second circle P and Q are the position of the points on the second circle. Now we are taken P, Q on the first circle and also the second circle. These points lies on the line joining C1 and C2. Then we are getting the maximum distance and minimum distance of PQ. Okay. So from this diagram we are observing, first we have to find the center and radius. What is the first circle center? 1, 0. Second circle center 4, 4. And first circle radius R1 and second circle radius is R2. Also are both equal to, that is equal to 2. And we have to find distance between the centers C1, C2. So C1 is 1, 0. C2 is 4, 4. Now I have to find C1, C2, that is 5. Distance between these 2 points 5. Okay. Where, so see from this diagram, observing here these lies between these values. So lower value is C1, C2 minus of R1 plus R2 is the lower value of D. And upper value of D is, the maximum value is C1, C2 plus R1 plus R2. So you are keen observing the diagram. When PQ, so if P and Q in between, so the least distance we are getting C1, C2 minus of their radius. C1, C2 minus R1 plus R2 we are getting the least distance, and the maximum distance here, maximum distance PQ is C1, C2 plus adding both the radius. C1, C2 plus R1 plus R2. Then we are getting the boundaries of small d. Okay. Here C1, C2 is 5, R1, R2 is 2. So we are getting 5 minus of 2 plus 2 is 4. That is 5 minus 4 less than or equal D less than or equal 5 plus 4. From that we are getting 1 less than or equal D less than or equal to 9. So that is the boundaries of the distance between P and Q. That is the answer. 1 less than or equal D less than or equal to 9. Next one is the largest distance from the point P of 2, 5 to the circle x square plus y square minus 4x plus 2y minus 4 is equal to 0. Now I have to find the largest distance from the point 2, 5 to the circle. That is a point on the circle. Okay. Now see the diagram. This is the circle, and center of the circle is 2, minus 1, and given point is P is 2, 5. So the largest distance from the P to the circle is PA. See in the diagram, from this diagram we are observing the largest distance from P to the circle is PA. How to find the largest distance? First of all, we find the center of the circle is 2, minus 1, and P is 2 comma 5. Now the radius of the given circle is we are getting 3. R is equal to 3. Now first we have to find CP distance. C point is 2 comma minus 1 and P point is 2 comma 5. Distance between these 2 points CP is equal to, we are getting 6 units. Okay, the largest distance from the point P to the circle is, observe the diagram, CP plus R is the maximum distance. We are adding the other radius, CA is the radius. We are adding CP plus CM, that is the maximum distance, that is CP plus R. What is CP here? 6. And what is the radius? R is equal to 3. So CP plus R is the largest distance from the given point to the circle. So that is CP plus R, 6 plus 3, that is 9. So 9 is the largest distance from the given point P to the circle. Suppose if we want the smallest distance or the least distance from the point P to the circle. What is the formula? CP minus R. That is CB in the diagram. CB is the least distance. PB is the least distance and largest distance is AP or PA. PA is the largest distance and PB is the smallest distance or shortest distance. Okay. So the shortest distance from the given point P to the circle is the formula CP minus R. Okay. Next one is the sum of the radii of inscribed and circumscribed for an n-sided regular polygon of side small a. Now we have to find the sum of the radii inscribed and circumscribed circle for n-sided regular polygon of side length is small a. That is given, length of the side of the polygon is small a. Here n-sided regular polygon is given. See the diagram. This is the n-sided regular polygon. Now we have to find the sum of the radii of inscribed and circumscribed radius. So that is our problem. So each length of the side is small a. So this is the circle, inscribed circle of n-sided regular polygon, and this circle is the circumcircle of the regular polygon. Now we have to find the sum of the radius. See the diagram. Cap R is the radius of the circumscribed circle and small r is the inscribed circle radius. So here length of the side is A from the diagram. So here angle is pi by n. So each angle is 2 pi by n. So that is half of the angle. So total angle is each side makes a angle at the center is 2 pi by n. So that is half of the length we have taken pi by n. From this triangle we have to find from the diagram, see that sin pi by n is equal to, what is the opposite side? That is the half of the side. So side length is a, half of the side is a by 2. What is the hypotenuse here? Capital R. So sin pi by n is equal to a by 2 by capital R. From that we are writing capital R is equal to a by 2 into cosecant pi by n. Again from this diagram, from this triangle, tan pi by n is equal to, what is from the diagram, what is tan pi by n? That is the angle. Tan pi by n. What is opposite by adjacent? What is opposite a by 2? That is this side. And what is here adjacent side? That is small r. A by 2 by r. From that we are writing small r is equal to a by 2 into cot pi by n. Now we have to find capital R plus small r. Now we are writing capital R plus small r. In this we have to common a by 2. A by 2 into 1 by, what is cosecant pi by n. That can be written as 1 by sin pi by n plus what is cot pi by n, cos pi by n by sin pi by n. We have to LCM, where LCM is sin pi by n. In numerator 1 plus cos pi by n. So what is 1 plus cos theta? 2 cos square theta by 2. So here simplifying, after simplifying, we are getting capital R plus small r is a by 2 into cot pi by 2n. That is the sum of the radii of inscribed and circumscribed of circle circumscribed for an n-sided regular polygon of side length small a. This is capital R plus small r is a by 2 cot pi by 2n. Okay. Next one is the center of the circle passing through 1 comma root 3 comma 1 comma minus root 3 comma 3 comma minus root 3. We have to given 3 points. Now we have to find the circle passing through these 3 points. We have to given 3 points. How to find the circle equation passing through 3 points? We have done in previous videos in IP concepts. So in this problem we have to given 3 points. Now we have to find the center of the circle passing through these 3 points. Okay. First of all, observe these 3 points form a right angle triangle. Then we are easy to find the center of the circle. How to find the center of the circle in the right angle triangle? Midpoint of the hypotenuse is the circumcenter. That is nothing but center of the circle passing through 3 points. Okay. So like these problems, most of all the given points forms a right angle. Observe this diagram. This is x-axis and y-axis. So here first 2 points having the x coordinates are same. If x coordinates are same, then these 2 points lies on a line which is parallel to y-axis. So see the diagram. 1 comma 3, 1 comma minus root 3 are the points, the line joining these 2 points which is parallel to y-axis. And next another last 2 points, 1 comma minus root 3, 3 comma minus root 3. These y coordinates are the same. So y coordinates are same, then the line joining the 2 points is parallel to x-axis. Now see the diagram. 1 comma minus root 3, 3 comma minus root 3 join the line which is parallel to x-axis. Y coordinates are equal, then the line is parallel to x-axis. So on observation, these 3 points form a right angle. Here 1 comma root 3, 1 comma minus root 3 parallel to y-axis, 1 comma minus root 3, 3 comma minus root parallel to x-axis. So the angle at 1 comma minus root 3 is the right angle. So it is a right angle triangle. In a right angle triangle, what is the circumcenter? That is nothing but the center of the circle. What is the circumcenter? Midpoint of the hypotenuse. Here, what are the coordinates of the hypotenuse? 1 comma root 3, 3 comma minus root 3 are the coordinates of the hypotenuse. So now we have to find the midpoint of the hypotenuse. That is the circumcenter. That is nothing but the center of the circle passing through these 3 points. Okay. It is the required circle. See the solution from the figure. It is a right angle triangle. In a right angle triangle, the midpoint of the hypotenuse is the center of the circle. So what is the center of the circle? Midpoint of 1 comma root 3 and 3 comma minus root 3. So from that 3 plus 1 by 2 minus root 3 plus root 3 by 2. That is we are getting 2 comma 0. That is the center of the circle passing through given 3 points. Okay. Next, see that the image of the circle x square plus y square minus 2x is equal to 0 in the line x plus y is equal to 2. Now we have to find the image of the line with respect to the circle. That is our given problem. Look at the diagram. This is this circle. This is the image of the given circle with respect to the line x plus y is equal to 2. Okay. First we have to find the center of the first circle, that is 1, 0, and we have to find the center of the image circle, that we are assuming C2 is h, k. Here radius of the first circle is 1, and we have to find the radius of the second circle. So first circle radius is 1. So since here h, k be the image of the point C1 1, 0 with respect to the line x plus y minus 2 is equal to 0. So now we have to find the image of the circle with respect to the given line. That is the meaning C1 is C2 is the image of C1 with respect to the line x plus y is equal to 2. Okay. Now we are using the image formula. Already we are studied in first year. What is the image formula? H minus x1 by a is equal to k minus y1 by b is equal to minus of 2 into x1 plus b1 plus c by a square plus b square. Using the image, what is the image of the point that is x1 h, k. Then using the formula we are getting the coordinates of the image of the given point. Okay. So that is the formula h minus x1. x1 is here 1. A is 1. That is a is ax plus b plus c. That is the line x plus y minus 2 is equal to 0. H minus 1 by 1 is equal to k minus y1. y1 is 0. K minus 0 by 1 is equal to 2 into ax1 plus by1 plus c. That is substitute 1, 0 in the given line. 1 plus 0 minus 2 by a square is 1 square plus b square is also 1 square. From that we are getting h and k values. Here h is equal to and k is equal to 1. This is the coordinates of the required circle center. That is C2 is we are getting 2, 1. And the radius is the same. Why? It is the image of the given circle. The circles having the same quantity. That is it is the image of the given circle. The radius, these two circles having the same radius. So the radius of the required circle is nothing but the radius of the given circle. Since these two are image to each other. So the center is we are obtaining C is 2, 1. Therefore the required equation of the circle with the center at 2, 1 and radius is 1. What is the circle formula? X minus x1 whole square plus y minus y1 whole square is equal to r square. From that formula we are getting x minus 2 whole square plus y minus 1 whole square is equal to 1. This is our required equation of the circle, which is the image of the given circle with respect to the given line x plus y is equal to 2. Okay. Next one. A line is at a constant distance small c from the origin and meets the coordinate axis in capital A and capital B. The locus of the center of circle passing through OAB. This is our problem. This is the circle. This is the x-axis, y-axis, and a line meets the coordinate axis at capital A and capital B. Now the locus of the center of the circle passing through OAB. That is, we have to find the locus of the center, capital C. If we have to take in locus of the center is x1, y1, that is the locus of the point. That is the center of the circle. So here the equation of the line AB is, we are knowing the C is the midpoint of AB. So that is the A and B are the points on x-axis and y-axis. So what is the line equation? If AB midpoint is x1, y1, then that line AB equation is x by x1 plus y by y1 is equal to. So if you know the midpoint of the line intercepted between the coordinate axis x1, y1, then that line equation is x by x1 plus y by y1 is equal to 2. This is the equation of the line AB. So here given that the distance from origin to this line is small c. Okay, given that small c is the perpendicular distance from origin to the line AB. So what is the small c is equal to, what is the perpendicular distance from origin to the any line is mod c by root of a square plus b square. So here what is the constant? Minus 2 by root of a is here 1 by x1, that is a square 1 by x1 square, b square is 1 by y1 square. Okay, so that is the distance formula. So we are using the distance formula. We are getting c is equal to modulus of minus 2 by root of 1 by x1 square plus 1 by y1 square. From that we are getting cross multiplying and squaring that, we are getting 1 by x1 square plus 1 by y1 square is equal to 4 by c square. So we are getting the x1 y1 locus. So what is the locus of c of x1 y1? We are getting the locus is here. In the place of x1 is x, in the place of y1 is y. We are getting the locus. What is the answer? Locus of the center 1 by x square plus 1 by y square is equal to 4 by c square. Otherwise another form, x to the power of minus 2 plus y to the power of minus 2 is equal to 4 into c to the power of minus 2, as like this. So okay, this is any form of the in the given options we are to choosing, we are converting the required form. Okay, so this is the answer, the locus of the center. Okay, next okay.